In this problem we're asked to calculate an observation period for a morning star sight, and we're given our DR position and the day of the 20th, and our ship's clocks were on UT plus 7 hours. So what we have to do is calculate for the 19th and the 22nd, as the 20th is not a middle day. So when we went into the tables on the 19th, we found that nautical at 20 degrees south was 0542, and 30 degrees south 0559, civil 610 and 628. What of course we want is 26 degrees. Now when we do use the tables for interpolating sunrise, moonrise that are in the back of the table, we have to go from the lower latitude to the higher. So we have to go by interpolation 6 degrees using the difference between these two here, 17 and 18. So in the 10 degrees tabular interval, go down to 6 degrees and go across and read, and we see for 15 minutes it's 9, for 20 it's 12. So we would use those values to work out the first time there. So on the 19th we get 0551 and 0622. We do the same thing for the 22nd. We looked up nautical and civil for the 22nd for 20 degrees and 30 degrees. By interpolation at 6 degrees we found it's 9 and 12 again. So on the 22nd and the 19th we now have nautical and civil times. The difference between these two is 1 minute over the 3 days, and there's no difference there. So there's no difference for interpolation between the middle days at all. So on the 20th of June, nautical twilight will be 0551. We've called it 0551 of course because the 19th is 0551 and we're looking for the 20th. That's why we don't call it 0552. And civil twilight 0622. Okay, so that's the nautical twilight and civil twilight LMT. What you've now got to do is apply your longitude and convert it to universal, and you'll notice that that takes us to the 19th of June universal time, and then we apply our ship's clocks UT plus 7 to give us the ship's time. So the local time isn't necessarily the ship's time. You must convert the local to universal using the longitude, and then having used the longitude, use whatever the ship's clocks are on to give you the ship's time. So the ship's time is 0511 and 0542 as opposed to 0551 and 0622 as the local mean time. So that's how we would get the observation period for a morning sight. So just be careful with that. And then just to recap, using the table at the back, the interpolation, you always go from the lower to the higher latitude, which is why we use the 6 degrees of the 10. Go across with your difference between them here, come down and do the interpolation that way. Of course, if you're unsure, actually written here in the almanac is an explanation of how you would do the interpolation.